Hi, hello guys. Welcome to Advanced Tire Maths with me, Mr. Garner. To me, just now at least, I don't know if it's going to be me for the full year, but I'm going to take you through the first part until whatever this is sorts itself out a little bit and we get back to normality. The way I'm going to do it, I'm going to do it with PowerPoints. I've already got these PowerPoints prepared, but I don't necessarily have the audio attached. So you might have to bear with me a little bit whilst I upload and record all this audio alongside the PowerPoints, but I'm going to upload the PowerPoint with my voice over, and you can follow it through that way, and then I'll also upload the slides so you can go through them at your own pace. So I basically go through the topic, go through some examples, and then what I'll do through Teams is I'll set you some work. Ordinarily I'd give you a textbook, or at least give you a PDF of a textbook, but I can't get the PDF that I need. I've emailed the company, and if they get back to me, I'll get that uploaded as well. But it might just be a case of me taking pictures of the textbook that I've got and you answering the questions from that. But I'm going to go through it. Obviously, you can't ask me questions as I'm doing it, but if you've got any questions once you've gone through it yourself on your own time, then you can email me any questions or send any questions on Teams. And then what I'll get you to do is upload some of your work so I can check it, and then we can move on. So ordinarily we'd have period once a day, so an hour every single day. I'm not necessarily going to give you 5 hours of work each week. It's going to be more like 3 or 4. But the advantage of all of this is that we have more time to do the whole course, so it can be spread out a little bit more. So we'll kind of go at that kind of pace and see how we get on. Okay. But as I say, if you've got anything you need to ask, anything you want to kind of run through again, you can just contact me whichever way you need. Right, so this is Unit 1. It's Methods in Algebra and Calculus. I think I typed that a year ago and never really realized it's what we were doing, but anyway, Algebra and Calculus. So the first part of this unit is partial fractions. Okay, so partial fractions is probably the most algebra you're going to get in this course. It's kind of, there's bits of it throughout the course, I guess, within the other aspects, but this is the only kind of solid algebra section I think you have in the course. It's relatively straightforward, and it's actually the reverse of something you already know. Okay, and I'm going to start by kind of showing you that in terms of your understanding of how it's going to work. Okay, so partial fractions is the process of returning a single fraction into the sum of 2 or more fractions. Okay, so this is more the kind of fractions that you dealt with in National 5. So when you're adding and subtracting fractions in National 5, algebraic fractions with a denominator something like x plus 1, you started with 2 fractions, you added them together and ended up with 1 fraction. This is the process of reversing that. Right, in itself, it's not the most useful of processes, but it's going to be useful when we need to differentiate something or integrate something. More importantly, integrate something that has a kind of an awkward fraction, and you might want to split it up into 2 fractions to make the differentiation or the integration easier. Further down the line, I'm going to look at that in terms of series and asymptotes as well. Okay, but don't worry too much about those 4 topics just now. Let's just focus on actually understanding partial fractions. Okay, so as I say, it's the reverse of adding or subtracting, I should say, in there, fractions. So in terms of what you already know, when you did National 5, you would have had a question like this. Okay, so 3 over x plus 2 plus 1 over x minus 3. So the denominators don't necessarily have to be different, but this is just going to give you a middle example of the kind of thing that we're looking at. So what's basically going to happen with partial fractions is this is going to be our answer. So we're going to go through this. So this is, as I say, a National 5 question, and what's going to be our solution here would be the question. We have to change that singular fraction, into these 2 fractions. Okay, we've got to work out a way of doing that. Okay, so it helps to know obviously the process, and hopefully you remembered all of this, but when adding 2 fractions together, we must have a common denominator. Okay, so we change them both individually so that they have that same denominator. So you're looking for the lowest common multiple of x plus 2 and x minus 3, which is x plus 2 multiplied by x minus 3. So you're going to do that for both of those fractions, change the tops accordingly. Once you've done that, you can combine the 2 tops together. And once you've done that, it's just a case of simplifying it into something like this. So as I say, the process of partial fractions is basically doing this in reverse. This would be our question. The question alongside it would say something like change this fraction into partial fractions, that's what we want to end up with. We want to split it into two or more, perhaps, different fractions. Right, there's a lot to consider in terms of this, and I'm going to go through this in stages. The denominators can be different, and there's very slight differences between the denominators that you have to look out for. And the main battle that you have with partial fractions is that you have to be able to spot what the denominator consists of, and then you have to change the numerator accordingly. Okay, you're going to see this, as I say, as we go through the process. Okay, but we're going to start with the most basic one first of all. Okay, which is when we have a partial fraction with a rational fraction whose denominator is a product of two functions. Okay, so something like this. This is just the last one we just had. So we're going to be using a lot in terms of standard variables. It doesn't really matter, obviously, the A, B, C, and D here is just the first four letters of the alphabet. It doesn't really matter here, but it's just to show a kind of a difference between the two denominators, and so on and so forth. Okay, so by reversing the previous example, we can see that the numerator started as a sum of multiples of the functions in the denominator. Okay, in which case we had this. So what we basically had here was we had the x minus 3 on the top and the bottom, the x plus 2 on the top and the bottom. Okay, and the top was, as I say, a sum of the multiples of the functions in the denominator. So you could rewrite it like this. Again, we're just introducing a bunch more letters. Don't worry too much about that. To be honest, this bit is probably going to confuse you more than the example that's to follow will. Okay. So doing this in reverse, we have no idea at this stage as to what the values of A and B are. Okay, so that's the main thing to see here. As you can hopefully remember from the question, and get up here. I don't have the question here. But basically, where you started with the two fractions that you started with in the question had nothing to do really with what we ended up with in the numerator. So there's a little bit of assumption involved in the initial part of partial fractions. Okay, and that's where these letters come in. Okay. Right, as I say, it's probably easiest to just start with an example. Okay, so what we're basically going to do, it says decompose. You've heard of that word before. It's basically split it up into partial fractions. There's lots of different ways of these being worded, and as I say, it might come up as part of something else. Okay, but this is the general idea. Right, first thing I want you to think about here is that this is distinct linear factors in the denominator. So this is the first type of partial fraction that we're going to be looking at. It's where we have, as I say, two different, okay, that's the meaning of distinct, linear, okay, so non-quadratic, nothing more than that, just kind of a straight line type equation, so it's just where the x is to the power of 1 factors in the denominator. So we've got two different linear factors in the denominator, okay, so this is one of several examples of partial fractions, and you have to spot them, and you have to change, as I say, what you're going to do accordingly, okay, right, that's not just flashing. Right, so we're going to start by writing the fraction in a general form. Okay, so similar to what I just showed you there. So this is going to help you every single time. You don't have to do this every single time. If you don't do this every single time, it will probably lead to mistakes. So I do want you to try and kind of get into the flow of doing this for every one of these partial fractions. As I say, just so that you don't get confused and you kind of doing what you're supposed to, and you're just making that next step a little bit easier. So our aim here is basically to take the fraction and split it up into two fractions where the denominators are x plus 1 and the other one is x minus 2. Okay, it might not necessarily be a plus at the end of it all. Okay, it might be a minus. We'll change that accordingly later on. But what we're going to have is we're going to have two different numerators. We've got a and b here. You can use any of the different letters you wanted to. Obviously not x, but just the standard a and b here just now. Okay, right. We know that these two things are equal. Okay, we've written that. We know that we can kind of get split this into partial fractions. Okay, we know it must have come from somewhere with two different fractions, x plus 1 and x minus 2 on the denominators. We don't know what the numerators were. Okay, but we know that these two things are equal. So we can start playing around with this in the same way that we've played around with equations before. Okay, we don't really like dealing with fractions. Okay, as long as these are fractions, it's a bit more complicated. But if we multiply throughout the whole thing by the denominator, so this denominator here on the left-hand side, we'll change this so that it's not fractions anymore. Okay, so everything's getting multiplied by x plus 1 and x minus 2. Okay, so again, remember back to your National 5, if you multiply this by x plus 1, x minus 2, you're just left with the 4x plus 1. If you multiply this individual fraction by the x plus 1 and the x minus 2, obviously the x plus 1 just cancelled out, in which case you're left with x minus 2 multiplying the a on the top. Similar idea with the second fraction. If you multiply this by x plus 1 and x minus 2, the x minus 2's will cancel out, in which case you're just left with x plus 1 on the top. Okay, so we've got something now that's a lot easier to deal with because, as I say, it doesn't have any fractions. But the problem at the moment that we've got, as we've had in previous topics is that we've got three different variables. Okay, you've got this a and the b that you've introduced. You have no idea what they are, and you've got this x, which it doesn't really matter what it is. Okay, so what we have to do now is we have to kind of almost create equations whereby we don't have the a and the b. Okay, the way to do that, okay, is to think of what will get rid of these brackets. Sorry. Okay, so you're going to change the x. You're going to let the x be something. And you're going to do a lot of this in terms of partial fractions. So we're going to make that x something so that the a disappears. Because if the a disappears, and obviously we've changed all the x's to a number, then we're only left with one variable. And if we're only left with one variable, then we can solve that equation. Okay, so what we're going to do next is we're going to let the x equal to something. Okay, I think I've done this right around. Okay, in which case we're going to let the x equal to 2. Okay, so by letting the x equal to 2, this bracket becomes 2 minus 2, which obviously becomes 0, and then 0 times by a is just 0. A disappears, all the x's become 2, and we're just left with the b, as you'll see here. So very, very simply, we get the b equal to 3. Okay, so let me just run through that just one more time for you. Okay, so if we make the x equal to 2, this becomes 4 times by 2, which is 8, and then plus the 1 is equal to 9. Okay, so on the left-hand side, we've got a 9. Here we've got 2 minus 2, which is 0, times by a is just nothing. So on the right-hand side, we have no a's, but we've got this part. We've got 2 plus 1, which is 3, times by b, which is 3b. So just by making x equal to 2, this whole equation simplifies to 9 equal to 3b, in which case b is going to equal to 3. So b is equal to 3 given these parameters. Okay? And we want to do the same kind of thing with the a. Okay? We want to find out what the a is. So to find out what the a is, we need to be left with this. Okay, in which case we want to get rid of the b. So in a similar way, we want to make the x something so that this whole thing basically becomes 0. So obviously if we make the x equal to minus 1, then that disappears. So by letting the x equal to minus 1, we end up with minus 3 equals minus 3a, in which case a equals 1. Okay, so just quickly for you, if x is minus 1, this becomes 4 times minus 1, which is minus 4, plus your 1 is minus 3. There's going to be a lot of negatives in this whole course, so you're going to have to be very, very clued in with your negatives, so be careful there. So minus 4 plus 1 is minus 3, so that's the left-hand side taken care of. Right, looking at this bit, just before we look at the a, if obviously it's minus 1 plus 1, that makes it 0. That's why we made the x minus 1 in the first place. Okay, so that becomes 0. So we have no b's, so on the right-hand side, there are no b's. When we make this minus 1, it becomes minus 1, take away another 2. Again, be careful with your negatives. That gives us minus 3. Times by the a is just minus 3a. If minus 3 equals minus 3a, then a must equal 1. Or as many steps it takes you to get from there to there, doesn't matter as long as you get your a equal to 1. Okay, and that's pretty much us done. Now that we know that a is 1 and b is 3, you want to write this out in full. Okay, so your initial equation, your initial fraction, sorry, 4x plus 1 over x plus 1 times by x minus 2 equals, and then it's just a case of substituting in, right? You've got to be very, very careful here. The a was over the x plus 1, the b was over the x minus 2. These can't be swapped around now. You could have initially wrote them differently, in which case this would match up at the end. So you could have had b over x plus 1 and a over x minus 2, in which case these would have just swapped around, but your final answer would have been the same. So just be very, very careful that you substitute your a and your b back into the right place. It's very specifically 1 over x plus 1 plus 3 over x minus 2. Right, you can check this. Okay, this is just a question. You're just adding fractions. If you wanted to check your answer, okay, it's the kind of thing that if you're obviously in an exam, you have a little bit of time and you're not quite sure about your answer, you can go and you can do this. Just add those two fractions together. Does it give you that? It obviously will, in which case you've checked your answer and it must be fine. Okay, so little things like that you can use to help you. Okay, but that's your first partial fraction. Right, I think I've got one more example to show you. I'll go through this anyway. We can use what we call a general form for putting a fraction that has distinct linear factors in the denominator. I don't know what this is on about. All right, okay. So this is just, you might want to copy this down. You're going to get a formula sheet. I'll maybe actually upload it at the start, but there's very little, well, there's nothing in partial fractions that's going to be on your formula sheet. The majority of the formula sheet actually comes in towards the end of Unit 2 and Unit 3. So there's not much that's going to be of use in your formula sheet just now, apart from your table of derivatives, which we'll get to this unit. Okay, but if you're talking about a general form for when you have distinct linear factors in the denominator, that would be it. It's not a formula that you need to learn as such. You just need to know that's what you need to do when you have distinct linear factors in the denominator. As I say, there's going to be a couple of these, and obviously I'll go through it in more detail when we have them all and give you plenty of practice on all of them at once, because that's going to be the battle. When you get to final exam, it's not going to tell you that it's distinct linear factors in the denominator. You have to establish that for yourself. Okay? All right, so that's the first one, and as I say, that's kind of a formula. It's not in a formula sheet, but you might want to learn it, or at least, as I say, know how to use it. Okay? So there you go. Yeah, so this is another type of example whereby you may have more than one. So it's still the same idea. We've still got distinct linear factors in the denominator, but we've just got an extra one this time. Okay, so obviously there's a slight difference in terms of the general form, slight thing that we need to change. All that's basically happening is we're going to have three fractions, in which case we're going to have a c as well. Okay, so we're going to split it into three fractions. We're going to have something over x plus 1, something over x minus 1, and something over x minus 2. Okay, as I say, you could have done them in a different order. This fraction could have been written in a different order. Just got to make sure that when you get to your final answer, that obviously the a goes back on top of the x plus 1, b goes back on top of the x minus 1, and so on and so forth. Okay. Right, I think this is where a lot of people kind of go wrong. They don't necessarily write this stage and they try and kind of rush the next bit. So be very, very careful. You're still going to do the same bit as we did in the last one. You're still going to multiply through by this denominator, okay? The idea being that we're getting rid of the fractions. So when you multiply by x plus 1, x minus 1, and x minus 2, think about what you'd get, okay? So obviously this whole fraction just disappears because if we multiply by that denominator, we're just left with the numerator. And then do each one individually. When you multiply this by x plus 1, you're just left with the a. But we're also multiplying by the x minus 1 and the x minus 2, in which case you've got a times by x minus 1, x minus 2. When you multiply the second fraction by x minus 1, obviously it just becomes b, and then you're left with multiplying by x plus 1 and x minus 2, and similar kind of idea for the c. Okay, don't make the mistake there. I think that's what, certainly when I was teaching this last year, that's where a lot of people went wrong. So it seems like you could rush that. It seems like it's going to be obvious, but I suggest you write it out every single time so as not to make any mistakes. Okay. Right, the next bit is just the same. We're trying to solve this. Basically, we're trying to solve this equation. We've got an extra variable now, so it might appear to be a little bit more difficult. But if you actually notice, what we've got is we've got the same fractions in two of the different variables, same brackets, sorry. In two of the different variables. So if I make this bracket x minus 2, if I make that 0, then this whole thing becomes 0 because I'm multiplying through by a 0, and then it will be the same applies here, okay? And then it'll be similar with the other variables that we're left with, okay? So what we're going to do first of all, so I've chosen this one. It doesn't matter which one you do first, but I'm going to let x equal 1. By letting x equal to 1, then this bracket becomes 0, in which case this whole thing becomes 0 because it's a times by 0. It doesn't even matter what that is. It will just become 0 overall. Similar idea with this one. So by making x equal to 1, we're getting rid of the a and the c in our equation, in which case we're just left with something in terms of b. Okay, so take your time with this, make sure you get this correct. So when x is 1, all of these x's become 1. So it becomes x, which is 1, squared, which is 1, times by 4, which is 4, minus 11 of those 1's, which is not minus 4. All right, because I'm adding the 3 on. Okay, so be careful there. Don't make the same mistake as I did. 4 minus 11 would be minus 7 plus the 3 is minus 4. Okay. All right, on the right hand side, as I say, this disappears, so we're just left with this. But be careful here. X plus 1, when x is 1, that becomes 2. X minus 2 becomes minus 1. 2 times minus 1 is minus 2, times by b is minus 2b. Put in more work in if you need to than I've written here, but just make sure you get to this stage. Minus 4 equals minus 2b, in which case b equals 2. Again, be careful with your negatives. Okay, so we've worked out our b, we've got the a and c to come, so now I'm going to let x equal to 2. If I let x equal to 2, the a disappears, and the b disappears this time, leave me with just the c. Okay, just make sure you double check that, just to check that it's actually worked, and then go through and replace all the other x's with 2's. 2 squared is 4, times by 4 is 16, 2 times by 11 is 22, so 16 minus 22 is minus 6, plus the 3 is minus 3. Over this side, that's disappeared, so we're left with this third part. 2 plus 1 is 3, 2 minus 1 is 1, 3 times by 1 is 3, times by c is 3c. If minus 3 equals 3c, then c must equal minus 1. And then all that's left to do is find the a, so we want to be left with this one, so we need to get rid of these two, so we're going to have to let the x equal to minus 1, so that these both become 0, and nothing here becomes 0. So what's going to happen later on is you're going to find there's a problem there, okay? But we'll come to that. By letting x equal to 1, as I say, we're getting rid of these last two. We've got to go through everything else. And again, be careful with your negatives. Minus 1 squared is 1, times by 4 is 4. 11 times by minus 1 is minus 11, but we're going to plus it. We're taking away a minus, so we're adding 11. So 4 plus 11 is 15, plus the 3 is 18. Over here, we're going to have minus 1, which is minus 2, minus 1, minus 2, which is minus 3. So minus 2 times by minus 3 is positive 6. Times by the a, 6a equals 18, a equals 3. Take your time if you need to. Do some working at the side. These might be long questions, but bear in mind this is advanced higher now, guys. This is going to take a little bit longer and be a little bit more difficult. Right, done everything we need to. We found our three parts of our fraction. We just got to make sure we put them back in the right place. The a was 3 over x plus 1. The b was 2 over x minus 1. And notice what I've done here. Okay, this is just the simplest way of writing it. Okay? Obviously now we're in advanced higher, that's just a given. If we can write anything simpler than it perhaps we already have, then generally the SQA are going to look for that to be the case. Okay, so it would be plus minus 1 over x minus 2. But obviously, if we're plus and minus 1, we're just taking away. So it's take away 1 over x minus 2, because obviously the c was minus 1. Okay. Right, I think that's enough to get you going. I need to go and actually find some pages and some questions for you to do. But as I say, go through this video as many times as you need to understand this. The beauty of me doing this is that further down the line when it comes to the exam, you're going to have this and you can look back over it if you need to. Okay, so what I might actually end up doing is doing this for the full year. But yeah, we'll cross that bridge when we come to it. But I'll upload the slides as well so you can kind of look through them at your own pace. Bear in mind that these are all animated, so if you just try and look at them without going into the presentation and PowerPoint, it will probably all be jumbled up, especially later on. So you might want to go through the presentation and actually look through the slides as I have done here. Okay, but you can do that at your own pace, try and work this out alongside any examples. And as I say, I'll upload the work in terms of what I want you to do. And then all I'll need is you to just submit some questions so that I can see that you're doing it correctly. Okay, but email me any questions, put anything on Teams, speak to each other. Yeah, but good luck.